Students, today we will revise lesson 4, carbon and its compound. Question is, how would you name the following compound? Compound is CH3, CH2 and Br. First write down the numbering. Bromo is at the 1 position, then 1 bromo. Methane and ethane, then it becomes the 1 bromo ethane. Because single bond is everywhere, it means ethane. It will be the ethane. Now next is H, C, H double bond O. Now this is the only one carbon. It means methane. This is the methane. And this is the aldehydic group. Aldehydic group have the suffix al. Methane and al, it means it become the methanol. This is the methanol. Now next is 1 2 3 4 5 6 carbon, and this carbon have the triple bond. This carbon have triple bond and remaining have the single bond. And we will give the numbering from the any group or from the bonding, triple bonding or double bonding as the priority basis. Now mark from here 1 2 3 4 5 6. It means it is hexane. And this have the triple bond. It means it is alkyne. This has the suffix ine. It means we will add the suffix ine and at the 1 position. You can write down now hexane 1, or you can write hex 1 ine. Both are the right. You can write both which you feel easy. This is the hexane. Methane, ethane, propane, butane, pentane, hexane and ine. Triple bonding is there. Hexane 1 or hex 1 ine. Why is the conversion of ethanol to ethanoic acid an oxidation reaction? This is because in this reaction oxygen get added to the ethanol. That's why it is called the oxidation reaction. CH3, CH2, OH. This is called the ethanol or alcohol. It is the type of the alcohol. And when we oxidize it in the presence of alkaline KMnO4, you will write down also this KMnO4. KMnO4. Then it will form the here hydrogen react with this oxygen and water is released from here. Now write down CH3 E and 1 oxygen combined with this and OH, and it will also form the water molecule as a product, and this is called the ethanoic acid or carboxylic acid. Because if you have remembered, then this is the functional group of the carboxylic acid. This is called the ethanoic acid, and this is the very important question from the exam point of view. A mixture of oxygen and ethane is burnt for welding. Can you tell why a mixture of ethane and air is not used? Ethane and oxygen is used. A mixture of ethane and air is not burned for welding. This is because air also contains nitrogen. Pure oxygen is, it means ethane react with the oxygen only. But air consists of the carbon dioxide, nitrogen and many more gases, and it is the mixture of the many gases. Then here nitrogen is also present. Nitrogen will also burn in oxygen, producing oxides of the nitrogen such as the nitric oxide and nitrogen dioxide, which cause the pollution. Next question. How will you distinguish experimentally between an alcohol and carboxylic acid? The following two tests are used. First is the litmus test. Treat the given compound with the blue litmus solution. If the blue litmus solution turns red, that means it is acid. And which is the acid? Here carboxylic acid is the acid, not the alcohol. And if it does not turn red, then it is the alcohol. Next test is sodium bicarbonate test. Add some sodium bicarbonate solution to the given compound if there is a brisk effervescence. If there is a brisk effervescence of the colorless and odorless gas which turn freshly prepared lime water milky, then it is the carboxylic acid, and if there is no effervescence, then it is the alcohol. With the sodium bicarbonate, acid gives the brisk effervescence and carbon dioxide gas is released. Question. What are oxidizing agents? The substance which can oxidize other substance by giving oxygen and itself get reduced. The substance which can oxidize other substance by giving oxygen is called oxidizing agent. Example is alkaline potassium permanganate solution and acidified potassium dichromate solution. These are the oxidizing agents. Would you be able to check if water is hard using a detergent? No, we cannot check whether the water is hard or soft using a detergent because we can use detergent even in the hard water. People use a variety of methods to wash clothes. Usually after adding the soap, they beat the cloth on a stone or beat it with a paddle, curb with a brush, or the mixture of is agitated necessary to get clean clothes. This is because when soap molecule dissolve in the dirt is somewhat loosened from the cloth, and in order to remove it from the cloth has to be beaten on a stone or with a paddle or the scrub with a brush, or mixture has to be agitated in washing machine. Next question. Ethane with the molecular formula C2H6 has the how much covalent bond? C2H6. First write down the formula C and H6. Here the number of covalent bond, if we write down the dot structure of this, then 1, 2, 3, 4, 5, 6 and 7. 7 covalent bond are here. Then the answer is 7 covalent bond. B answer is right. Butanone is a 4 carbon compound with the functional group butanone. If we write down the butanone, ONE is the suffix. It means it is the ketonic group. It is the C double bond O ketonic group, and here ketone is the right answer, and the answer C is right. While cooking, if the bottom of the vessel is getting blackened on the outside, it means that fuel is not burning completely. If there is yellow flame in the gas or burner, or if it blackens the utensil, then it means burning is not complete. Answer is B. Explain the nature of the covalent bond using the bond formation in CH3Cl. The formation of CH3Cl can be represented as CH3Cl. If we draw the structure CH3 and Cl, this is the structure. Carbon forms single covalent bond with the 3 hydrogen. Here it forms the single covalent bond with the 3 hydrogen. And chlorine atom, by sharing chlorine, also have the 1 electron, because chlorine atomic number is 17 and its electronic configuration is 287, and it will gain 1 electron. It will gain 1 electron or share. It will share. Chlorine will share 1 electron with the carbon, and carbon have the 4 valency 1, 2, 3, 4, and by sharing one electron pair with each CH bond are non-polar, but CCl bond is polar. This is the polar bond. But these three are non-polar bond. Because CCl bond is polar, because C and H have almost same electronegativity. C and H have same electronegativity, where chlorine is more electronegative. Chlorine is more electronegative than the carbon. Question: draw the electron dot structure for the ethanoic acid. Ethanoic acid. Ethanoic mean ethane, methane and ethane. Oic acid. Oic mean carboxylic group. C double bond O OH. Now C double bond O OH. Now satisfy the valency of this carbon. 1, 2, 3, 4, 2, 3, 4, and this oxygen share double bond 1 and 1, 2. One with the carbon and one with the hydrogen. And this is the structure. Now you will draw the dot structure of this ethanoic acid. This is the electron dot structure of the ethanoic acid. Now next is H2S. H2S. Now sulfur atomic number is 16 and its electronic configuration is 2, 8 and 6, and it will share 2 electrons, or it will gain 2 electrons to complete its octet. Now sulfur comes in between because it will share 2 electrons, one with this hydrogen and one with this hydrogen, and this is the electron dot structure of the sulfur. Next is propanone. Propanone. Propane 5 carbon and ONE group is ketonic group. Ketonic group is C double bond O. Now methane, ethane, propane. And now satisfy the valency of this H. 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. This is the, now we will draw the dot structure. Oxygen share double bond. This is the electron dot structure of the propanone. Next is F2. Chlorine is atomic number is 9 and electronic configuration is 2 and 7, and it will gain 1 electron to complete its octet. It means it is exist in the F2 form, and one F share 1 electron with this F, and this is the electron dot structure of the chlorine. Now next question is, what is an homologous series? Explain with an example. A series of compounds having similar structural formula, same functional group, and hence similar chemical properties. It have all same similar structural formula, similar functional group, and similar chemical properties. They is called the homologous series. In the homologous series, any two adjacent members differ by CH2 group unit in their molecular formula. For example, homologous series of aldehyde can be represented as methanol, ethanol, propanol, butanol. All these have the same functional group. It means these are aldehydes, and all the aldehydes have the similar chemical properties, similar functional group, and similar structure. This is called the homologous series. Next question, how can ethanol and ethanoic acid be differentiated on the basis of their physical and chemical properties? Ethanol, it is colorless liquid having a pleasant smell. It is colorless liquid having a vinegar-like smell. Ethanoic acid have vinegar-like smell. Ethanol have no action with the litmus solution, but ethanoic acid, it is an acid, weak acid, it turns the blue litmus solution red. Ethanol. Ethanol has no action with the sodium hydrogen carbonate solution, but ethanoic acid gives the brisk effervescence and carbon dioxide gas is released with the sodium hydrogen carbonate solution. Why does micelle formation take place when soap is added to a water? Will a micelle be formed in other solvents such as ethanol also? Soap molecule has two ends. One is hydrophilic and it dissolves in the water, while the other end is hydrophobic and it dissolves in the hydrocarbon. When soap is at the surface of the water, the hydrophobic tail of the soap will not be soluble in the water and the soap will align along the surface of water with the ionic end in water and the hydrocarbon tail pointing out of the water. Inside water, these molecules have a unique orientation which keeps the hydrocarbon portion out of the water. This is achieved due to the formation of cluster of molecules in which the hydrophobic tail are in the interior of the cluster and the ionic end are on the surface of the cluster. This formation is called the micelle. In the simple language, when the detergent is added in the water, then it forms the cluster. This cluster is called the micelle. This cluster is called the micelle, and in this soap and detergent molecule have the two parts. One is the head and one is the tail. Head is called the hydrophilic end, and this tail is the hydrophobic tail. And when agitation takes place in this, then this dirt will repelled by this tail and this dirt is released from the cloth. Since micelle can be formed in the other polar solvents like the ethanol. Here, carbon and its compound used as fuels for the most applications. Carbon and its compound are used as a fuel for most applications because they burn producing a large amount of heat and light. Explain the formation of the scum when hard water is treated with the soap. When soap is added to a hard water, the soluble calcium and magnesium salt present in it react with the soap to give the insoluble calcium salt of the soap and which produces the scum. C17H35COONA, this is sodium stearate or soap structure, and CaCl2, this is the calcium ion present in the water, make it hard, and calcium, it will make the calcium stearate or the scum. This is C17H35COO square Ca plus NaCl. What change will you observe if you test soap with the litmus paper red and blue? Soap solution will turn red litmus paper blue because soap is alkaline in nature. It means basic in nature, and base give the blue color with the red litmus solution. What is hydrogenation? What is its industrial application? Addition of hydrogen to unsaturated hydrocarbon. Addition of hydrogen to unsaturated. Unsaturated means which have the double or triple bond. This is called the unsaturated hydrocarbon or ethene. And when we added hydrogen to this and in the presence of catalyst palladium and the nickel to give saturated hydrocarbon. When hydrogen combined with this, then it will change into the CH3 single bond CH3. It means unsaturated hydrocarbon change into the saturated hydrocarbon by adding the hydrogen in the presence of catalyst palladium and nickel. This is called the hydrogenation, and in the industry it is used for the liquid vegetable oil using a nickel catalyst to get artificial or vanaspati ghee. Then we will obtain vanaspati ghee by this process. Which of the following hydrocarbon undergo addition reaction? C2H6, C3H8, C3H6, C2H2 and CH4. Out of C2H6, C3H8, C3H6, C2H2, CH4, C3H6 and CH2H2 undergo addition reaction because they contain the multiple bond. As we have discussed now, if there is any unsaturated hydrocarbon, then it will go the addition reaction and form the saturated hydrocarbon. Here C2H6, if we draw the structure, then there are only the single bond. It means it is saturated, then it will not show the addition reaction. If we draw the structure of the C3H8, 3, 2, 6, 7, 8, 9, C3H8, 1, 2, 3, 4, 5, 6, 7, 8, C3H8. It will also not show the combination or the addition reaction because all are having single bond and it is saturated. Now we will draw the structure for C3H6, C3 and H6. H6. Now 1, 2, 3, 4, 1, 2, 3, 4. But this carbon have only 2 valency. It means we can mark one bond here and one bond here. It is mean it is unsaturated. Then it can show the addition reaction C3H6, C2H2, CCHH, 1, 2. It means we can mark here triple bond 3 and 1, 4, 3 and 1, 4. It is unsaturated hydrocarbon and it show the addition reaction. It means C3H6 and C2H2 both show the addition reaction because they contain the multiple bond. Now what is the difference between the butter and cooking oil? Butter, it is solid at the room temperature. Cooking oil is liquid. Mix equal volume of HgCl2 solution in 50% alcohol and 5% iodine solution in alcohol. To this add 1 gram of the butter. Violet color does not fade away. Mix equal volume of HgCl2 solution 50% alcohol and 5% of iodine in alcohol. To this add 1 milliliter of cooking oil. Violet color will fade away. It will not fade the violet color but it will fade the violet color. Take 2 gram of butter in a test tube. To add 1 milliliter of concentrated HCl and a few drop of 2% perfural solution in the alcohol. Shake and allow to stand for 5 to 10 minutes. No rose red coloration appear. Take 2 gram of the oil in a test tube. Add 1 milliliter of concentrated HCl and a few drops of the 2% solution in the alcohol. Shake it well and allow to stand for 5 to 10 minutes. Then rose red color is obtained. But in butter, no rose red color is obtained. Explain the action of soap in removing only spot from a piece of the cloth or the cleansing action of the soap. Mechanism of cleansing action of the soap is soap are sodium or potassium salts of the higher fatty acids. That is, example is sodium palmitate and sodium stearate. A molecule of the soap consists of the two parts, a long chain hydrocarbon part which is soluble in the oil and ionic part of the polar group which is soluble in the water. Thus, a molecule of soap can be represented as a soap molecule has two parts, a long hydrocarbon chain hydrophilic part soluble in the oil and ionic part hydrophilic part soluble in the water. This is the head. The long hydrocarbon chain is insoluble in the water but soluble in oil and grease, whereas the ionic or polar part is soluble in the water. Soap has the capacity to clean a dirty piece of the cloth, whereas ordinary water cannot. The dirty clothes contain greasy and oily substance. Soap molecule dissociate in water to give carboxylic ion and cation. When soap added to the dirty cloth dipped in the water, the hydrocarbon part of the carboxylate group dissolving in greasy or oily dirt particle whereas the polar group remain attached to the water. In this way, each oil droplet acquire the negative charge, and these negative charged oil droplet called the micelle cannot form a stable emulsion in the water. These small droplets along with the dirt can be easily washed away with the water. Thus, the soap helps in removing greasy dirt by producing a stable oil in the water type emulsion. Also, the soap reduces surface tension of the water, hence cloth is wetted more effectively and is clean. This is the cleansing action of the soap and detergents. Thank you.